Staring down a blank triangle without the right formulas can quickly make you feel like you've hit a wall. But by the end of this video, you will confidently calculate the sine, cosine, and tangent for your very first trigonometry problem. This diagram shows how we map the exact relationship between the angles and sides of a triangle. It's the exact same logic engineers use to construct skyscrapers, build suspension bridges, and program 3D video games. Go ahead and grab a pen and a piece of paper so you can work through our final practice problem alongside me. Mastering these three basic fractions gives you the foundational tools required to design the physical world. Let's get to work. Step 1 is to draw a basic right triangle on your paper. We need to correctly label its three sides based on our reference angle, which we will call theta. Take a look at this diagram. The longest diagonal side is your hypotenuse. Next, find your reference angle, theta. The side directly across from it is the opposite side. That leaves the bottom line, right next to our angle. We call this the adjacent side. Pay close attention to where your reference angle sits. If theta moves to the top corner of the triangle, your opposite and adjacent sides will swap places. The hypotenuse always remains the same. Correctly identifying these three relative sides is mandatory. Once you have them mapped, the actual math becomes incredibly straightforward. To remember how to organize these sides, we use a 9-letter memory trick, so, ka, toa. Let's break that sequence down. The first part, so, tells us that sine is calculated by dividing the opposite side by the hypotenuse. Next is ka. This means cosine is calculated by dividing the adjacent side by the hypotenuse. Finally, toa shows us that tangent is calculated by dividing the opposite side by the adjacent side. Take a second to write these three empty fraction formulas down on your paper. Committing this single phrase to memory ensures you will never plug the wrong side into the wrong equation during an exam. Let's apply this to a standard right triangle. Here we have an opposite side of 3, an adjacent side of 4, and a hypotenuse of 5. To find the sine, we check our so formula. We take our opposite value of 3 and our hypotenuse of 5, giving us a sine of 3 over 5. For the cosine, we look at ka. We divide our adjacent 4 by the hypotenuse 5, resulting in 4 over 5. And for the tangent, we use toa. We divide the opposite 3 by the adjacent 4, which gives us 3 over 4. Look at the difference on your page. You started with a blank, intimidating shape, and you now have 3 cleanly solved fractions. By defining these specific ratios, you have successfully translated abstract geometry into simple, solvable algebra. Great job working through that. You've just completed your first full problem and proven that trigonometry is highly approachable. This exact math scales up to solve massive problems, calculating orbital trajectories for aerospace engineering, and keeping GPS satellites perfectly synced with our phones. Build on this with a daily practice habit. And remember, the moment you sit down for a math exam, write so, ka, toa at the top of your paper before you solve a single equation. Mathematics is a reliable set of logical tools designed to make understanding the world vastly easier. Keep practicing, and be sure to subscribe for more step-by-step lessons.